Graph the following key features of the function above, the y-intercept. Well, I'm just going to write my formula above it, so it's easy for me to just line up the numbers. So y-intercept is our c value, and c is lined up with 5, so I'll go ahead and plot 5 on my graph. The axis of symmetry, so for the axis of symmetry, we have to use negative b over 2a. So negative b is 6, a is 1, so that will be negative 6 over 2 times 1, which will become positive 6 over 2, which means x will be 3. So we know that the axis of symmetry is at x equals 3, and we also know that the x value of the vertex will be there. Now to find the y-intercept, we're going to plug 3 back into the equation. So 3 squared minus 6 times 3 plus 5. So all I did was plug 3 in for x and x here. So that becomes 9 minus 18 plus 5, which is negative 9 plus 5, which becomes negative 4. So that means the y value is going to be negative 4. So I'm just going to go ahead and put 3, negative 4 here, x equals 3 here, and our y-intercept is 5. Just go list them. So negative 3, 4. All right. And then concave up or down, it's going to be concave up because our a value is positive. And then I want to get a third point on here, so I'm going to reflect this point, our y-intercept, across our axis of symmetry. Because remember, the axis of symmetry cuts the parabola in half perfectly. So we can get another point on the other side by reflecting the point, which you've learned in 9th grade. So this point is 3 away, 1, 2, 3 away from the axis of symmetry. So I'm going to go 3 to the right, 1, 2, 3. And that'll give us a perfect symmetry for the parabola, and then we'll just sketch a rough graph from here. And if we wanted to check our function in Desmos, let's go ahead and do that. Awesome. You'll see that I already plugged it in. And I changed n of x to f of x because it won't read n of x. But you'll see that our y-intercept is at 5, and then we have another point here, and that our vertex is 3, negative 4. So we have 5, we have 3, negative 4. Looks pretty good to me.